Okay, we have F.IF.7.a. This is functions. We are interpreting functions. So the IF stands for interpreting functions. This is standard 7 and subpart A. We are continuing our talks on graphing linear functions. And this is video 2. Today we're going to be graphing using intercepts. And if you recall from video 1, we were graphing linear functions using standard form. We were creating function tables. Sometimes we were given the defined domain. They gave us all of our x values, and we had to substitute into the equation and find our range values. And today we're just going to do a different type of graphing, and I think it's kind of a more simpler form. When you have intercepts, it's easy to graph some lines. So let's take a look at that. And before we do, I want to also mention in the standard here that we are only dealing with graphing linear functions, and we are not going to be talking about quadratics, maxima, and minima. So let me cross that out for you once again. Again, we're going to do that more at the end of the school year. We're going to be graphing quadratics. So let's eliminate quadratic, maxima, and minima and focus on linear functions. Okay, a few terms to know. Please take out your journals, write down these two terms, and you can define them and bring those to class with you. All right, we're going to begin with a picture here. We have a red straight line going through the coordinate plane, and you're going to notice two particular points. And since we're talking about intercepts, let's find those two particular points that I'm talking about. So when you're talking about an intercept, you're talking about the point at which your red line, or whatever color you have for your line, crossing your axes. So if this is our y-axis going vertically, let me just label that right here. This is your y-axis. That means where my cursor is right here, your red line is crossing your y-axis. So we call that the y-intercept. And vice versa, if I were to take my cursor and pull it all the way down here to where my red line crosses the x-axis, let's label that. This is your x-axis. We would call this the x-intercept. So there's a few key features that I want you to know about intercepts. The x-intercept has particular ordered pairs. So if I were to graph the x-intercept ordered pair, I would count from my origin. I would go 1, 2, 3 units to the left. So my x coordinate would be -3. And my y coordinate, if I were to go vertically, it doesn't move, so we are at 0. If I were to go to my y-intercept, let's just write that over here. My ordered pair would be what? Can you figure out the y-intercept? Starting at the origin, we would go, what? Left or right first, so we don't go anywhere in terms of the x-coordinate, so we would call that 0. And then we follow up to, where is that going to go? Right here, so we would go up 1, up 2, so we have 2 as our y coordinate. Okay? Now that's going to make more sense after I have my second example here. I'm going to throw this red line out for now. I'm going to pull in this green line. And let's see, where could I throw this? Why don't we go here? Okay. So I'm going to take my cursor and let's start with the x-intercept again. So that's where we have our x-axis and where my green line is crossing it or intercepting it. I have an ordered pair. And that ordered pair is going to be start from the origin, 1, 2 to the right. So we have 2. And once again, we didn't move anywhere vertically, so we have 0 as our y-coordinate. Shifting gears, let's go to the y-intercept and graph its ordered pair. And we have left and right horizontally. We aren't moving anywhere, so we are at 0 once again. And then we go upwards 1, 2, 3, 4. Okay. Do you notice anything about the x and y intercepts right now in terms of the number values that are inside of your parentheses? Okay, good. You're going to notice every time we have an x-intercept, whether it be the green line or the red line, the x-intercept shows that the y values are always going to be 0. And on the converse, we have the y-intercept. The x values, no matter what, will always be 0. So that's taking a look at it in terms of the graph, in terms of the picture of this. If we were just given an equation, like you see right here, and it says find the intercepts of the graph of an equation, this is just another way of graphing without having to create function tables. So we can just do it mathematically. So I'm going to drag the given equation to find the x-intercept. Now, from the last screen, what do you recall about all x-intercepts? Yes, the y-coordinate will always be 0. So I'm going to substitute in my equation. Wherever I see a y, I'm going to plug in a 0. And since I've eliminated the y value by plugging in a 0, I'm going to be solving for the x coordinate. So we have 3x plus 0, because 2 times 0 is 0, equal to 6. So a simpler form, I have 3x equaling 6. Inverse operations like we've been working on. Divide both sides by 3, so x is equal to 2. So if I were to want to go to a graph and put this on the coordinate plane, I know that I have one ordered pair known as x2, and since I chose y to be 0, there's my first intercept. Now, how many points do you need on a grid to create a straight line? Yes, you need 2 points. So I have one ordered pair, or 1 point. Now I need a second point, and I'm going to use the y-intercept. Okay, what will we do here now to find the y-intercept? Well, on the previous screen, you recall that when we're finding the y-intercept, no matter what, your x values will be 0. So it's kind of the opposite. So 3, substitute in a 0. And now you're going to be solving for the y value. And your inverse operation, solve for y. So y is equal to 3. So if I were to have an ordered pair of the y-intercept, x would be 0 and y would be 3. Okay, so we have 2, 0 and 0, 3. If we go to the grid now and I plot my points of 2, 0 and 0, 3, we go, here's 2, 0. Here's 0, 3. And we get our straight edge out. 2 points make a line. And we graph all the way through the grid. Let's see if I can't pull that up. All right. And we have the equation of the line. And if we want to name it, it's 3x plus 2y equals 6. So grab your pencils, give it a name. 3x plus 2y is equal to 6. Noting your intercepts right here, your x-intercept and your y-intercept. So no need to create a function table. Sometimes it's easier just to use intercepts. Make a special note, please, in your notebook. If we were to have a line that did not have a slope, like you're either going to have a vertical line or a horizontal line running parallel to your axes, you're only going to have one intercept. So if I were to quickly draw that for you, let me try to get rid of this here. All right, let's clear that off. So what I was saying is, if you were to have a, let's just call it a vertical line, and it's running parallel to your y-axis, how many intercepts are you going to have? Are you going to be able to do 2 intercepts here? No, you're only going to have 1 intercept because there's no slope to the line. There isn't any slope, so we're going to have just the x-intercept. And if we were to have a horizontal line, and that one is running parallel to the x-axis, you're only going to have a y-intercept. Okay. Please pause the video. Give this one a try yourself. Stay away from that function table if you can, and I'd like you to use the idea of intercepts. So find your x-intercept and your y-intercept, and we'll go graph this. Pause the video. Okay, so if I were to find the x-intercept, we know that we have the equation that's given. And what do we need to do to find the x-intercept? I hope you plugged in a 0 for your y. Let me just solve this out. So x is equal to -5, and we have our first ordered pair being x is -5, and we use 0 as our y because that's our intercept. Okay, now let's move over to the right and find our y-intercept. Same equation used. And now we're going to substitute in the x value with a 0. And y is equal to 3. So our second ordered pair is x is 0 and y is 3. So now we go graph that. So we have -5, 0 and 0, 3. -5, 0, and 0, 3. Let me double check. 0, 3. Okay. Grab your ruler, your straight edge, and connect your points. And you should have 2 intercepts running through your grid. I can do that for you also. You should have a line that looks similar to this one. Let's straighten that out for you. Precision is key. You want to make sure that you're precise when you are graphing straight lines. You don't want to freehand these. You really need a straight edge because what you're doing is you are making sure that all of the points that are on this line, all these little ordered pairs, these fractions, these mixed numbers right in here, these are all solutions to your equation, all of your x's and y's that will work. And if your line is a little slanted or a little off, you're not showing the viewer that you have the correct ordered pairs that are the solution. So do your best to really connect these points using precision. Okay, in your journal, please define the given terms on page 2 of this flip chart and write a few sentences on what you think you learned from the video. Maybe there was something new to you. And jot down a few questions that you might have, something that might have been confusing to you, some of the wording, maybe part of the standard that was confusing, and bring those questions to class, and we will all work together to answer those questions for you.